Hello guys, welcome again to my channel. Today here comes another nice challenge which reads 4 to the power of x plus 2 to the power of 2x minus 1 equals to 3 to the power of x plus 1 over 2 plus 3 to the power of x minus 1 over 2, and we are looking for the possible value for x. So please, if you are new here, kindly subscribe, and by the time you subscribe, please don't forget to turn on the notification button so that you get notified anytime I drop videos on mathematics. So let's see how we can solve this nice challenge. So the first thing I can do is a solution. Then write the question. We say 4 to the power of x plus 2 to the power of 2x minus 1 equals to 3 to the power of x plus 1 over 2 plus 3 to the power of x minus 1 over 2. Okay, haven't done this, what are we going to do? Can write down the question with 4 to the power of x plus 2 to the power of what? 2x. Recall from a basic principle of indices, which says if you're having a to the power of b minus c is also equals to a to the power of b times a to the power of what? Minus c. So if we should put this principle here, we can have this to be 2 times 2 to the power of what? Minus 1, right? Equals to 3 to the power of x times what? 3 to the power of 1 over 2 plus 3 to the power of x times what? 3 to the power of minus 1 over 2. Okay, this is what we are now having. Having done that, what are we simply going to do? We can write the question 4 to the power of x plus 2 to the power of what? 2x times, recall, if you are having a to the power of minus 1 also equals to 1 over a. So if we should do that here, we can have this to be times 1 over what? 1 over 2. 1 over 2 is equals to 3 to the power of x times we are having 3 to the power of 1 over 2, right? If we are having 3 to the power of 1 over 2, we can still write c to be this. If we are having a to the power of 1 over 2 is also equals to the root of what? Of a. So if we do that here, we can have this to be root of 3 plus 3 to the power of x to the plus 3 to the power of x times, we are having this is going to come down, we are having it to be 1 over root of 3, because you can see it's having a negative sign, then it's going down and it's going to take a square root. The principle we applied here, we also apply it here, but this one is not going down because of the negative signs. So having done this, what are we simply going to do? We can write this to be 4 to the power of x plus 2 to the power of 2 all to the power of x times 1 over 2. From the principle of indices, which says if we are having, let's write it here a little bit. We are having a to the power of bc is also equals to a to the power of b or to the power of c. So this principle is what we applied here. So it's also equals to 3 to the power of x times the root of 3 plus 3 to the power of x over, let's put it in at this denominator, over root of 3. Okay, having done this, we can simply write this to be 4 to the power of x plus this and 2 to the power of 2 is going to give us 4, so we are having 4 to the power of what? Of x over 2, because we are bringing this to the denominator of this, is equals to 3 to the power of x root 3 plus 3 to the power of x over root 3. So this is what we are now having. This is now the simplest form. So what are we going to do again? Now we can easily what? Factor out. We are having at this left hand side, we are having 4 to the power of x as a common factor, and on this right hand side we are having 3 to the power of x as a common factor. So if we factor them out, we can have this to be 4 to the power of x open bracket 1 plus 1 over 2 close bracket is equals to, factor this out, becomes 3 to the power of x open bracket 1 plus 1 over root 3 close bracket. Okay, having done this, what are we simply going to do again? We can say 4 to the power of x, open bracket. We can look for the LCM. If we look for the LCM, we're having this times this is going to give us 2. 2 plus 1 is going to give us 3. So we're having 3 over 2, close the bracket, is equals to 3 to the power of x, open bracket. This, recall, we are having root 3 here. So we are having root 3 here. Root 3, because by the time we factor out, we're having what? Root 3. So this point is root 3. So if you look for the LCM of this times this is going to give us 3 plus 1 over root 3, close the brackets. So since we've gotten this, we can have this to be 4 to the power of x, open bracket, 3 over 2, close the bracket, is equals to 3 over x, so 3 to the power of x times 4 over root 3, because 3 plus 1 is going to give us 3. So we're not having 3 plus 1 is going to give us 4. Sorry, we're not having 4 over root 3. So this is what we're not having. We're not having 4 to the power of x times 3 over 2 is equals to 3 to the power of x times 4 over root 3. So what are we simply going to do from here? We want to make s to stand, the value having s to stand on its own, and the value that is not having s to stand on our own. So if we should do that, we are going to divide both sides by 4 to the power of 3 and 3 to the power of x, 3 to the power of x, and we are going to divide both sides by 3 over 2. So if we should do that, we are having 4 to the power of x over 3 to the power of x is equals to 4 over root 3 divided by 3. We are dividing by this 3 over 2. So this is what we are not having. So having done that, so what are we simply going to do? Let's move on and solve. So if you come here quickly, we can easily demarcate this part. So what are we not having? We are not having 4 to the power of x, right, over 3 to the power of x is equals to, so we want to turn this one to a multiplication sign. So simply put this one up, then put this 3 down. So we should do that. We are having 4 over root 3 times what? Times 2 over over 3. Okay, we are now having 4 to the power of x over 3 to the power of x is equals to, this times this is going to give us what? It's going to give us 8 over 3 root 3. Okay, recall from your simple indices, if you are having a to c over b to c is also equals to a over b or to c. So if we should put this principle here, we have this to be 4 over 3 or to x equals to 8 over 3 root 3. So how can we look for x? Some people can say, okay, we can easily look for x by taking the log of both sides. Actually, I'm not going to apply the logarithm here, but I can still solve this without applying the logarithm. So let's see how I can solve this. Okay, since we're not having this 4 over 3 or to the power of s is equals to 8 over 3 root root 3, and I said we can look for the value of s without multiplying both sides with the natural log or with the log value. So how can we look for the value of x in this? Okay, we are going to apply a little mathematical logic. Recall your 8 is equals to what? The root of what? Of 64, right? Root of 64. And this 3 root 3 is equals to 3 root 3 is also equals to 3 to the power of 3 over 2. What do we mean by 3 to the power of 3 over 2? 3 to the power of 3 over 3 is trying to tell us it's also equals to the root of 3 times root of 3 times root of what? Of 3. So if you multiply this with this, is going to give us 3. Then multiply it with this is going to give us what? 3. So we are now coming back to what? 3 root what? Root 3. So we are now having this backward. So you can now see that 3 root 3 is also equals to 3 to the power of 3 over 2. Okay, and we said 8 is equals to the square root of what? Of 64. So we are now having 4 to the power of what? 4 over 3 or to the power of what? Or to the power of x is equals to, so in the place of 8 we can put what? Root what? 64. So we can say root 64 over, in the place of what? 3 root 3, we can put 3 to the power of 3 to the power of 3 over 2, right? So we can say 3 to the power of 3 over 2. Okay, and recall, we can say 64 is also equals to 64 is also equals to what? It's also equals to root 64 is also equals to 64 to the power of 1 over 2. Root 64 is equals to what? 64 to the power of 1 over 2. In other words, I can say this is also equals to what? 64 all to the power of 1 over 2. We're having 1 over 2 here, all over 3 to the power of 3 over what? Over 2. Okay, so we're now having this to be 4 over 3 all to x is equals to your 64 is also equals to 4 to the power of 3. So 4 to the power of 3 is 64. So we can say 4 to the power of 3 times 1 over 2 over 3 to the power of 3 over 2. So which implies we're now having this to be 4 to the power of 3 over 2 all over 3 to the power of 3 over 2. So we are now having 4 to the power of what? Of 3. 4 over 3 to the power of x is equals to this and this, they are common. We can easily bring them out, right? So we can say 4 over 3 all to the power of 3 over 2. Since both of them are the same, you can see that this base and this base, they are not the same. So by comparison, our x is equals to 3 over 2. So this is our value for x. So if you substitute this value of x into our previous equation, whatever the value is in the left hand side will be the same value at the right hand side. So if you find this video useful and interesting, please don't forget to click on the subscription button and turn on the notification bell. Bye for now. God bless you. Jesus loves you, and see you in my subsequent video. Bye bye.